Hi, I'm Tate, and this project is community plastic recycling. A problem with plastic is the large volumes produced, but the end of life not being considered, likely due to the current linear economy framework followed by most people. The main way to combat the linear economy is by changing the mindset to that of a circular economy, where products are reused, repaired, or recycled at the end of their life. A large contributor and resource of the project is Envirohub. They are a charitable organisation in Tauranga that are taking some waste materials from the community and using them to make other products. They are extremely interested in teaching more people about the circular economy. Envirohub uses machines and frameworks developed by the Precious Plastics Enterprise to achieve their goals. They were an integral part of the whole project, being a source of recycled material and contributed ideas and suggestions for the duration. Firstly, what is 3D printing? 3D printing is a new manufacturing technology that generally is used for making small models or for prototyping new designs in the engineering industry. 3D printers can take computer files and build them layer by melting a material. This type of 3D printing is called fused deposition modeling and is the main printing technology used. The main aim of the project is to teach children about the benefits of the circular economy through innovative methods with the hopes of reducing waste. The material is to be looked at as polypropylene due to the fact that in the Tauranga curbside recycling it was not included, even with a lot of food packaging and containers being made from it. The aim will be achieved through both research and development components. The research side will focus on the investigation of the different ratios of virgin and recycled polypropylene. This will be done by confirming how much recycled material can be made into a usable filament without too big of a drop in material properties. This process will be done through testing to look at the extrusion behavior, how the different ratios print, and the material properties such as thermal testing to see changes in melting temperatures. The completed thermal testing of the samples with little processing displayed a drop in melting temperatures as the ratio of recycled plastic increased. This is significant due to the fact that it demonstrates the recycling process had indeed decreased one of the material properties of the polypropylene. Originally, 7 ratios were proposed and manufactured, up to but not including the filament extrusion step. Successful filaments originally included the 100% virgin polypropylene, 90-10, and 70-30. And with the failure of the 50-50 filament, the 60-40 ratio was made and was also successful. This led to the determination of the 60-40 being the greatest amount of recycled material capable in the extrusion of a filament. For the development side, the objectives are to produce a design that can be used in conjunction with a 3D printer to teach younger generations about the circular economy. The design process followed first starts with consultation by talking to people and also carries on from the research phase, as that included learning how more commercial extruders work. The definition side looks at defining what functions, features, and other things could benefit the design. The idea generation then looks at rough concepts to see how all operations can work together, and the detailed design takes one of the concepts and further refines it in order to get an idea ready for prototyping. Due to the environment the design is likely to be used in, some considerations also need to be made, as making sure children can learn from it, follow strict health and safety regulations, size and transportability so it can be easily taken places, and functionality as it needs to produce a filament that can be used in 3D printers. The final design, after all considerations, was drawn on SolidWorks CAD software. The education influence resulted in adding a view window on the outer shell of the enclosed system, as well as a material view window in the screw assembly so people could see some of the processing. The extraction fan was added to be used in conjunction with an off-the-shelf system to treat the air coming out of the extruder, to ensure no harmful chemicals were entering the classrooms, as most rooms where it will be used are not equipped with fumigation hoods. The hopes for the end of the project are to ensure the growing generation learns more about the circular economy and can, in the future, lead the charge to changing how we live. Thank you.